We're on the rooftop of the engineering building. This is a typical air handler. This provides the heating and the cooling and the ventilation for the building below us. If we open it up, we can look inside and see what the controls look like. This panel here contains all of the temperature control devices. We have a digital control system here on the front with controls. Inside we have all basically the guts of the can. We have pneumatic actuators to control the dampers and the heating and cooling valves. We have relays that power up and turn various things on and off within here. So these devices here are what we call the variable frequency drives. We have one for the supply fan and one for the return fan. You'll notice the supply fan is larger because the supply fan has it's a larger amperage motor. This side is really just the nuts and bolts. These are our contactors. This is our thermal protection down here for the motor, so we don't overheat and burn up our motor. So we have some big transformers up in here. Most of the things in here you don't want to touch; it will ruin your day. But what we wanted to look at today was to see how a frequency drive works and how it changes the amplitude and frequency of the voltage signal in. And by doing that, we can actually control very accurately the speed of our motors. So that's what these devices do. We control the speed because we don't always want our fans running at 100%. There's times when there's nobody in the building, but we need a little ventilation, so we'll back those fans off to 20, 30, 40%. And that's the reason for these. It's a money-saving device too. It costs a lot of money to run these big motors all the time, so that's what this does. This is where our power is coming into our VFD right here. If you look right here, it says line, so that's our input. So we come in here, we go through the controls, but some things to point out in here that are kind of interesting. You'll notice back in here in the back, these round things, those are two giant capacitors, a little bigger than we use in lab. If you'll notice these beige colored devices, these are actually giant resistors across those capacitors. So you have a really big RC circuit right here. These little devices right here are current measuring devices. They actually measure the current that we're putting out to the motor. So what we want to look at today with the frequency analyzer is we will actually look at the frequency of the current as it's going into the frequency drive, and then we'll actually look at it as it's coming back out of the frequency drive right here. Okay, this is a Fluke 41B. It's a power harmonics analyzer. We use this to analyze the frequency that the frequency drive is putting out to the motor, and we're actually trying to test to make sure that the total harmonic distortion out of this meter is less than about 5%. Right now the frequency drive is operating and we're putting out 47.4 hertz to the fan. So we're not at 60 hertz, we would be running at 460 volts and the 32 amps we were looking for. So right now it's adjusting those things. If we look at what the frequency looks like, you can see our fundamental frequency right here, and we're running between 70 and 80% of our fundamental frequency. You see I have a lot of noise, extra frequency harmonics back in here. Here we can see what our sine wave looks like. Here you can see we're up now to 50 hertz, gotcha. Running at 20 amps. This is the supply fan. This is the AC motor right here. It's an induction motor. This is a 25 horsepower motor. It runs on 460 volts. And it runs at about 32 amp. If we go above that, we'll burn it up. This is connected by a belt and pulleys, shivs, to the supply fan. So this is inside of this housing is a negative pressure, which would probably be about an inch or so of negative pressure inside of here. You see this turns the fan, turns the wheel counterclockwise here, and we blow the air into the other part, which is the supply pressure, and we might develop upwards to 5 inches of static on the supply side of this fan. But we use that variable frequency drive to control how fast this guy's turning, and therefore control how fast our fan is turning, which changes our static pressure.